All right, number 3. Here's number 3. Yeah.
Okay, wait, this is my. Do you do your constant divided by your?
Yeah, what you solve for.
I did, but it got
Inverse tangent?
Yeah,
You don't
I got it
have-
wrong.
Okay, I'll help you later. If you're having individual problems, like something's not working when you put it in the calculator or something like that, just wait until the end. I want to get this video made first, and then we can work on the individual issues later. All right. Number 3 is a good one. All right. So basically, number 3, what it's telling you is there's planet X and then the Earth. All right. There's an object. In my problem, it said the object on planet X. Okay. On Earth, it takes 3.1 seconds. So you could say like this. T on Earth is 3.1 seconds in my problem. That's what it gave me. And it says on planet X, it takes 1/5 the time. Or sorry, no.
Acceleration. That's different. 1/5 acceleration.
1/5 the acceleration. That's what it was. Yeah, that's a lot different.
Was 1.96.
Okay. 1/5 the acceleration. There's a couple of ways that you could work out this problem. Right? You could assume, well, you know the acceleration on Earth is 9.8, so you can do 1/5 times 9.8 and solve it that way. I think that would work. There's a way you can set it up to where it would work. This is how I did it, and I think this is probably the best way. So you can simplify the change in y equation since there's no vi. Right? This, we're assuming that it's falling from rest. So this becomes this. Delta y is equal to 1/2 a t squared.
I feel like we always use this equation.
It's a very common one because this is the equation for the parabola, right? One of the things that you need to realize is in this problem, they're falling the same height. Otherwise, it wouldn't be useful to compare the two things, right? It takes it 3.1 seconds to fall some height x. This one has 1/5 the acceleration, right? So we can say that delta y for each planet, whatever you want to say, is the same. So we can set 1/2 at squared on each planet equal to each other. Right?
Wait, why?
Since delta y is the same on each
Because you're dropping.
same height, yeah. Okay, so this is the equation that I ended up getting. So I said, yeah, I'm going to do it over 2 because it looks a little bit prettier. So g on Earth, which we know is 9.8, t squared over 2, has to equal, right, this. Okay, g on planet X, t squared over 2. They have to be the same, otherwise their heights wouldn't be the same. So what we can do is we can, on this side, since we said it's 1/5 the acceleration, on this side we can change it to look like this. 1/5 the acceleration on Earth, t squared over 2. Okay, this is going to be, sorry. I'm confusing you because I'm plugging this in on the wrong side. The other thing that I forgot, this is what I forgot to label the first time. You need to label the times too because the times are different. So GETE and GXTX, meaning acceleration of gravity on Earth, time on Earth, the acceleration of gravity on planet X, time on planet X.
Why can't we just make the gravity?
Because we don't know the height. That's the problem.
Wouldn't the height just be?
No.
Would that change the gravity?
All right, so what I can do here is on this side, I can put in, instead of GX, I can put in 1/5 GE. All right, so we're going to say GE t squared, TE squared is over 2 is equal to 1/5 GE TX squared. These are different time values. That's the important part, over 2. Okay. From here, I can reduce a lot of things and get an equation that helps me out. The 2's cancel out, right? We can multiply through everything by 2 to get rid of those. Anyone see anything else that cancels? The GE's cancel. All right. So when I rewrite this equation, I'm going to save this flip chart, by the way, and put it on my website. When I rewrite this equation, this is what I get. TE squared is equal to 1/5 TX squared. All right. And since we're trying to find out the time it would take on planet X, now I just solve for TX. And when you do that, you're going to get tx is equal to the square root of 5te squared, squared.
That's the answer.
I'm gonna- Yeah, so you could reduce this if you wanted. I didn't want to confuse you, but since Sam mentioned it, you could reduce this to the square root of 5te. Square root of 5 times te.
No, square root will cancel the square.
No, it wouldn't.
You can't, you still have to have square root of 5.
Oh, that 2 is just for that T.
Yeah, this is just, yeah.
Different, okay, yeah.
So you could reduce it to this if you wanted to.
But you still have to find T on Earth. So you
Yeah,
do the
but we
Y.
know t on Earth is, on mine it was 3.1 seconds. So you just plug that in there.
Holy Jesus Christ.
Okay, so there,
You'd be
a problem like this, so I know like Max said he tried just doing 1/5 times 9.8. The issue is you aren't given the height. You don't know enough information to do that. So you have to make that assumption that the heights are the same. That eliminates a variable for you. And then you have enough to work with. Yeah.
Square root is over everything, right?
In this one, yes. In this one, no. Because I reduced te squared, the square root of te squared is just te.
That was number 3, right?
That was number 3.
That was wrong.